we clean up this chapter, we have looked at the skew profile of trend following strategies by aggregating our data in using the mean value function as well as the median value function. So what happens if we want to be somewhere in between, and where the mean value function looks at all of our data points, whereas the median value function basically ignores all but one of the data points that sits right in the middle? We can try what is called a winsorization. So what is winsorization? Let's take a look at, let's create a list. So we would take list, let's take mp.array, and we're going to pass in the range of values from 10, and this is our values. Let's add 1 to it, and let's go ahead and winsorize. We can specify the limits, so maybe we are interested in cutting off 10% of the quantiles from the left and the right of the distribution. Actually, I think the winsorize function does not come from NumPy. We're going to do SciPy instead. Do we have SciPy installed? We do. So let's do from scipy.stats.mstats import winsorize. Alright, so can we run this function again? And now you see, okay, we have basically replaced 1 with the closest value, which is 2, and we can change the tails of this. So for example, here we can say instead of winsorizing 10%, we winsorize the 20% tail, and you can see both 1 and 2 is replaced by the closest value, which is 3. So basically the idea is that the winsorization is somewhere in the middle between a trade-off between the mean value as well as the median value. So that is the approximate explanation of the function. Of course, I encourage you to take a better look at what the function is actually doing and the statistics behind that. So we're going to import scipy.stats.mstats winsorize, and maybe we're going to do an aggregation where we winsorize, say, 5% of our data in each data bucket, so maybe 5% here. After we have done the winsorization, we still need to take the mean value of that, because winsorize produces a data of the same dimensions. So let's do this, and we obtain a positive relationship between the y and x variables. Okay, so you can take a look at how you can affect the different limits and whether this affects the nature of the relationship between our explanatory and our response variables. Okay, so that is basically just the idea behind what I wanted to talk about in terms of the regression approach, and perhaps we would just make a copy of this and we will name this regression.py, and we're going to go ahead in the next chapter. We're going to look at the backtest approach of things, and once we have looked at the backtest, this will help us to generate some position sizing, and we can use this position sizing to actually implement that as part of a portfolio for live trading.